Hi everyone, welcome to the new session of engineering mechanics. Today we will be discussing few more problems in connection with the motion of connected bodies. Today we will be discussing 4 problems. 2 problems I will discuss in detail and 2 problems you have to complete by yourself. Okay, we'll go to the first problem. As you can see in the figure, one body is resting on an inclined surface and another body is hanged by a pulley. So we'll read the question. Determine the resulting motion of the body A, assuming the pulleys to be smooth and weightless as shown in figure. If the system starts from rest, determine the velocity of the body A after 10 seconds. Here it is marked body A. So we have to calculate the acceleration of the body A after 10 seconds. Okay. So we will be applying Newton's second law or D'Alembert's principle for the motion of the bodies. So we will be applying F is equal to ma or F minus ma is equal to 0 for these bodies. First we will consider the 10 kilogram mass body and we will analyze what are the forces acting on that body. So its weight will be acting in the downward direction, which has two components, horizontal and vertical components. The horizontal component will be 10 sin 30. As it said, 10 kilogram is the mass of the body. We will be dealing with the weight of the body. First of all, we have to multiply it into 9.8. So we will convert the mass into weight. Its horizontal component will be 10 into 9.8 sin theta. And its vertical component will be 10 into 9.8 into cos theta. So if 30 is here, this angle will be also 30. So this will be 10 into 9.8 cos theta. And whatever weight is acting on the surface, which is given by the reaction of the surface. We need the reaction for calculating the frictional force. For analyzing the forces in the body, we will be considering tension of the body, the force in the horizontal direction, and the friction which is opposing the motion, which is given by mu into reaction of the surface. Okay, the reaction can be obtained by the force acted by the body on the surface, which is 10 into 9.8 cos theta. So reaction we will be calculating using the equation m2 g cos theta, that is 10 into 9.8 cos, it is not 10, it is 39, so equal to 98 into 96.5 Newton. Okay, so we will be converting it into frictional force, which is given by mu into reaction, that is mu into 96.5, which will be 19.3 Newton. Okay, so we got the frictional force, and other forces acting on will be T towards right direction and 10 into 9.8 into sin theta in the towards left direction. So we will be calculating the net force acting on the block will be T. As the block is moving towards right, we will be taking the force towards right as positive. So T will be taken as positive, and opposing forces mu into R, that is 19.3, and m2g sin theta, which is will be taken as 10 into g into sin alpha, that is 30 degree. So we will be considering all the forces and we will be equating it into mass into acceleration. So mass of the body is equal to 10 and acceleration we have given as a. So we got the first equation as t minus 68.3 is equal to 10a. And next we will be analyzing the block 15 kilogram. It will be moving downward with an acceleration. We will be analyzing what are the forces acting on this block. The first force will be its weight, which is given by 15 into 9.81, and in the upward direction we got two tension, that is T plus T. So total 2T will be acting in the upward direction. So total force acting on this block will be 15 into 9.81 minus 2T. So we will be taking 15 into 9.81 positive because the body is moving in the downward direction. The force in the downward direction will be taken positive. So we will be taking test 15 into 9.8, it is the weight of the body, and net force 147 minus 2t. And while dealing with the acceleration, this rope, if the body is moved by 1 meter, that 1 meter will be shared by these two ropes. So this block will be moving downward by only 0.5 meter. So whatever be the acceleration of this block will be divided by 2 to get the acceleration of the block B. If we are substituted the acceleration of block A as small letter a, we will be substituting the acceleration of block B as a by 2. So 15 into a by 2 or 15 by 2 they have written as 7.5. So total 7.5 a. So our first equation is this and second equation is this. We got two unknowns and two equations. So by solving this, we will be obtaining the value of acceleration and tension. So in the question, we have asked to find out the velocity of the body after 10 seconds. We got the equation velocity is equal to u plus at. V is equal to u plus at. As the block is started from the rest, the initial velocity can be taken as 0. And we are calculating the velocity after 10 seconds. So we can use the equation V is equal to u plus at. So the total velocity can be written as V is equal to u plus at. U is equal to 0. A is we already calculated 0.4 and T is 10 seconds. So 4 meter per second is our total velocity. Okay. So we will go to the next problem. Here in this question, we are asked to find out the acceleration of the body B and the tension in the string. Compared to the previous question, there is one change. In the previous question, we have two strings in the right side and we have only one string on the left side. And in the previous question, they had given the angle as 30 degree. Now it is given as the slope as 4 by 3. If the slope is given, you can calculate the angle by using the equation tan theta is equal to opposite side by adjacent side. So from that you can obtain the value of theta, and mu is given. So we will applying Newton's second law for the block B and block A separately. We will be formulating two equations, and by solving these two equations, we will be obtaining the value of tension and acceleration. Okay, so please complete this question as your homework. Okay, we will move on to the next question. So in this question, we have two blocks resting on two inclined surfaces. One is 15 kilogram block resting on a 30 degree inclined surface and a 5 kilogram block resting on a 15 degree inclined surface. So from the figure itself, we can tell that the 15 kilogram block will be moving downward and 5 kilogram block will be moving upward. So we will be applying Newton's second law in the block A and block B, and we will be finding out the required value. So in the question, we are asked to find out the resulting acceleration. So first of all, we will find out the reaction force by this 15 kilogram and 5 kilogram on each surface. First of all, I will be writing the weight acting by the 15 kilogram. It will be 15 into 9.81, and it will have two components, one perpendicular to the surface and another one parallel to the surface. The perpendicular surface is given by 15 into 9.81 into cos theta. As this is 30 degree, this will be also 30 degree. So it will be cos 30. And this component will be 15 into 9.8 into sin theta. So whatever is the force acting on the surface, which will be offered by the reaction of body. So we can write the equation for reaction of the 15 kilogram block on the ground is given by 15 into 9.81 into cos 30. That is the reaction for the first block. So we will write the equation for the reaction of the first block as 15 into 9.81 into cos 30. This is the reaction. And due to this reaction, there will be a friction. So as you know, the 15 kilogram block will be moving downward. The friction will be acting in the upward direction. And its value will be given by mu into R1. And R1 we have calculated, it is 127.3 degrees. So the total reaction force will be 38.2 Newton, which will be acting towards the up direction, towards right. Okay, and we will be analyzing the total force acting on the body, which is given by the tension and the horizontal component of the weight. And before that, we will be writing the reaction which is caused by the 5 kilogram weight. The 5 kilogram weight, weight will be acting downward direction, which is given by 5 into 9.81, and it got two components, vertical along perpendicular to the surface in which resting, and horizontal parallel to the surface in which resting. And this will be 5 into 9.81 cos 15 degree, and this will be 5 into 9.81 sin 15 degree. So whatever will be the force acting on the surface, which will be offered by the reaction of the surface, and the reaction will contribute towards the friction. As the block is moving upward, the friction will be acting in a direction which is opposing the motion. So which is given by mu into R2. The mu is given as 0.3, R is given by 5 into 9.81 into cos 15. So we will be writing the equation for reaction to R2 5 into G into cos alpha, 5 into 9.1 cos 15, 5 into 9.8 into cos 15, so total 48 Newton. So the frictional force is given by mu into R2, which is 14.4 Newton. And for now we will be analyzing or applying the Newton's second law of motion for the two bodies. We will be analyzing for the first body, that as the body is moving downwards, the downward force will be taken positive, and other two forces, T and friction, will be opposing direction, so it will be taken negative. So mg sin theta, so I am 15 into 9.81 into sin 30 will be taken positive, and tension and 38.2 is the frictional force will be taken negative. This is our first equation, and we will be writing the resultant force equation for the second body. That is, if the body is moving upwards, so T is taken as positive, and the frictional force and the weight component will be in the opposite direction, so these two will be taken negative. So T minus 5 into 9.81 sin 50 minus 14.4, which is the frictional force. Total equation equal to T minus 27 is equal to 5a. By solving these two equations, we will got the value of acceleration as 0.42 meter per second square. So that is the solution for the given question. So we will go through one more problem, which is almost similar to the previous problems we have discussed. I am not explaining anything in detail about this problem. You have to submit this as a homework. Okay, thank you. We will see for the next session.